So very good morning everyone. This is Dr. Ajay Gupta. I am the leader of Dept.Of Prosthodontics in Mahatma Gandhi Dental College and Hospitals. So today we will discuss regarding the principles of tooth preparation. We will cover this topic under the following headings, starting with the introduction, the objectives of the principles, then biological considerations, mechanical considerations, and the aesthetic consideration, then some common errors while the tooth preparation, and the conclusion. So starting with the introduction, so first of all, the why we need to prepare the teeth. So this is basically to create the space for the material that make up the crown, and because the teeth don't have the regeneration ability, so we need to prepare the tooth. Then tooth preparation may be defined as the mechanical treatment of dental disease or injury to the hard and the soft tissues, restores a tooth to the original form. So starting with the objectives of tooth preparation, we have the following objectives. The first and the foremost is to reduction of the tooth in miniature to provide the retainer support. Then the preservation of health and the tooth structure to secure the resistance form. Then provision of for the acceptable finish line. Performing the pragmatic axial tooth reduction to encourage the favorable tissue responses from the artificial crown contour. So according to Schellenberg, we have the 5 principles. These are the preservation of the tooth structures, retention and resistance form, structural durability, marginal integrity, and the preservation of the periodontium. According to Rosenstiel, we have 3 principles, that is biological, static, and the mechanical. In biological principles, we have the conservation of the tooth structure, avoidance of over contouring, supramarginal gingival margins, harmonious occlusion, and the protection against the tooth fracture. In mechanical, we have retention, resistance, and the deformation. In aesthetics, we have minimum display of the metal, the maximum thickness of porcelain, the porcelain occlusal surface, and the subgingival margins. So starting with the biological considerations. So during the tooth preparation, the structures easily damaged that may be the adjacent teeth, the soft tissues, and the pulp of the tooth. In prevention of damage during the tooth preparation, we can save the adjacent teeth by the higher fluoride concentration of undamaged surface. The interrupted layer is more prone to the plaque retention and erosionic damage, and we can save with the matrix band or with the enamel of teeth, the adjacent teeth. We can provide a metal matrix band around the adjacent tooth, and the preferred method is to use the proximal enamel of the tooth being prepared for protection of the adjacent structure, and a slight lip or fin of enamel we can preserve while the tooth preparation. Then the soft tissue of the tongue and cheeks, we can iatrogenically harm all of those structures. Then interaction with the aspiration tip, mouth mirrors, or the flange of the saliva ejectors. The great care is needed to protect the tongue when the lingual surface of the mandibular molar is being prepared. Like this. This is the swab adapter. Then prevention of damage during the preparation. The pulp. In the diagram, we can see the area of pulp with the age group. In the younger age, we have the broader area of pulp, so we need to protect the tooth surface more. And in the older age, the pulp area is shrink, so we have the better structure to prepare. So the great care is also needed to prevent the pulpal injuries during the tooth preparation and restoration. The thermal injury of the pulp may be prevented by the adoption of the following measures. That is, the first is the speed of reduction. We can intermittently, in a steady controller manner, we can use the preparation or use of coolants. That is the water spray we have in the aerators. Then prevention of damage during the tooth preparation. We can have the chemical injury also and bacterial injury if we are not doing it properly. So dental materials like bases, restorative resins, solvents, and luting agents applied to the freshly cut margins, and cavity varnish are effectively as barrier. And the bacterial injury is that either were left behind a micro leakage, and dental materials, that is antibacterial effect, we can use all those of teeth. So but it is most important to remove all the caries part before the restoration are placed. Then the conservation of tooth structures. The tooth structure is conserved by the employing the following guidelines. The first is the use of partial coverage rather than full coverage crowns. Second is the preparation of tooth with the minimum taper with the axial walls. Third, the occlusal reduction following the anatomical planes to the uniform to give the uniform thickness of the crown. Then the preparation of the axial surfaces so that the tooth structure is removed evenly. If necessary, we can reposition the teeth with the orthodontic treatment. Then selection of a conservative margin compatible with the other principle of the tooth preparation. So avoiding of unnecessary apical extension of the preparation. So first and foremost is the axial reduction. So gingival inflammation around the crown or abutment tooth is because inadequate axial reduction. So patient is unable to clean area around the gingival margin. So sufficient axial reduction must be occur, particularly interproximal area and the furcation area where the gingival inflammation starts. Then the marginal placement, wherever possible, the margin of the preparation should be supragingival. So the advantages of supragingival finish lines are easily finished, easily kept. We can keep it clean. The impressions are more easily made with the less potential for soft tissue damage. The restoration can easily be evaluated at recall appointments. Like this, we can have the supragingival margins. Then indication of our subgingival margin. The first and foremost indication is dental caries. If the caries is extended till the apical margins, then we can go for subgingival margins. The dental caries, cervical erosion or restorations exceeding subgingivally and where the crown lengthening procedures are not indicated. The proximal contact area extending to the gingival crest. Need for additional retention. The masking of margin of metal ceramic restoration behind the labiogingival crest. The root sensitivity that cannot be controlled by the more conservative procedures, and anterior region where aesthetics is of a prime consideration. Like this, we can go for subgingival margin also. Then margin adaptation. The junction between a cemented restoration and the tooth is always a potential site for recurrent caries because of dissolution of the luting cement and inherent roughness. So margins must be smooth and even, and it is well adapted. Like this. Then margin geometry. The guidelines for margin designs are easy of preparation without overextensions, easily identifiable in the impression and on the die, a distinct boundary to which the wax pattern can be finished, the sufficient bulk of material, then the conservation of the tooth structures. So there are three main requirements for successful restoration margins. So first is they must fit as closely as possible against the finish line of the preparation to minimize the width of exposed cement. Then they must have sufficient strength to withstand the force of mastications. Then whenever possible, they should be located in the areas where the dentist can finish and inspect them and the patient can clean them. The finish lines is defined as the point at which a preparation terminates on the tooth is called as a finish line, that you can see in the diagram also. There is well defined margins you can see, and it is also defined as the peripheral extension of a tooth preparation. So types of finish line we have: feather edge, chisel edge, chamfer, heavy chamfers, bevel, shoulder, slope shoulder and bevel shoulder. So starting with the chamfer finish line, the indication of this finish line is the cast metal crowns, because we can finish these crowns in shorter dimensions, and the metal only portion of PFM crowns we can finish. Then chamfer, then distinct, easily identifiable and least stress we have in this finish line. The round and taper diamond we use for preparation of this finish line, and half the tip of the diamond we should incorporate. So this is a diagram showing how a chamfer finish line end up. This is the cavus surface angle, that is 135 degree, and this is the tooth preparation and the margin you can see in the diagram. Then we have heavy chamfer, that is indicated for all ceramic crowns. So 90 degree cavus surface angles with a large radius rounded internal angle, round and taper diamond. So better than a conventional chamfer but not shoulder. Bevel added to use for the metal restorations. The heavy chamfer finish line provides a better support for a ceramic crown than does a conventional chamfer, but it is as good as a shoulder. A bevel can be added to the heavy chamfer for the use of a metal ceramic restorations. Then we come to the shoulder finish line. It is basically used for all ceramic crowns and for the metal ceramic crowns. The wide ledges resistance to occlusal forces minimizes stresses with leads to fracture of porcelain, or we use a flattened tapered board to make this finish line. This provides healthy contour to the tooth and the maximum aesthetics. Now it should form a 90-degree angle from the axial surface to the unprepared tooth structure. The wide ledge provides a resistance to occlusal forces and minimizes stresses that might lead to fracture of the porcelain and maximum aesthetics. So less conservative type it is, and some authorities have recommended a heavy chamfer rather than a shoulder margins. Then we have a sloped shoulder, that is 120 degree sloped shoulder margin, and this is a facial margin of a metal ceramic crown. We can use it, and no unsupported enamel, yet sufficient bulk to allow a thinning of the metal framework to a knife edge or acceptable aesthetics. Then we have slope shoulder as a 120 degree slope shoulder used as an alternative to the 90 degree shoulder or for the facial margin of metal ceramic crown. It is the advantage of this finish line is to reduce the possibility of leaving unsupported enamel, and the indication of this type of finish line is for the metal ceramic crowns. Then we have a modified shoulder, that is the cave surface angle, it is 90 degree, a shoulder with a lessened with the rounded internal angles. And this is the advantage of this finish line is lesser the stress concentration and good support for the porcelain. Then we have a shoulder with the bevel finish line. The indication of this finish line is the proximal boxes of inlays, onlays, occlusal shoulder of onlays and mandibular 3/4 crowns. The facial finish line of metal ceramic restoration, that is the gingival aesthetics, not critical. The situation where the shoulder is already present, we can make the bevel. So advantage of this finish line is provide bulk for the material and advantage of bevel also. And a drawback of this finish line is the less conservative and the extent preparation the periapically. Now the objectives of beveling are threefold: to allow the cast margin to be burnished against the prepared tooth, to minimize the marginal discrepancy caused by a crown that fails to seat completely, and to protect the unprepared tooth structure from chipping. A shoulder or slope shoulder is preferred over bevel shoulder because of biological and aesthetic reasons. And the knife edge of type of finish line will permit acute margin of metal. The axial reduction may be fade out. The thin margin difficult to wax and cast, and this is susceptible to distortion. The basic indication of this kind of finish line is mandibular posterior teeth with the very convex axial surface and a lingually tilted lower molars. Then we have feather type of finish line that is not sufficiently distinct. Restoration must be over contoured to possess adequate rigidity. Occlusal cervical irregularities in the finish line are more likely to be present. The making is much more difficult to fabricate a restoration that fits accurately. This is the feather edge. Then we have the chisel edge kind of finish line. The chisel edge is nearly same as the feather edge. In chisel edge, there is a angle between the axial surface and the unprepared tooth surface. This side of finish line is associated with the more taper, which is not correctly aligned with the long axis of the tooth. The indication is occasionally on the tilted teeth. Under circumstances, the feather edge and chisel edge are unacceptable. The reduction depth of this kind of finish lines on the metal margins, we have chamfer 0.3 to 0.5 millimeter. Axial surface reduction is 0.5 to 0.8 millimeter, and ocular reduction is 1 to 1.5 millimeter. Then we have metal ceramic crowns. The finish line depth is around 1 to 1.5 millimeter, and ocular reduction is around 2 millimeter. And for all ceramic restoration, the finish line and the facial reduction depth is approximately 1 millimeter, and in sagittal ocular reduction is around 2 millimeter. Reduction uniformity, at least uniformly reduce normal crowns from the improved aesthetics and makes easier for laboratory technician to create aesthetic restoration, and best achieved by the placing the depth grooves. The line angles should be rounded. Sharp line angles provide a more stress concentration that can cause a fracture of the tooth. Then facilitates laboratory fabrication and fit and ease of for the impressions. Then occlusal consideration, a satisfactory tooth preparation should allow the sufficient space for developing a functional occlusal scheme in the finished restoration. Then prevention of the tooth fracture. The likelihood that a restored tooth will fracture can be lessened in the tooth preparation is designed to minimize the potential destructive stresses, that is the inlay, onlay and complete crown. So this is the first diagram shows how inlay work, second the onlay, and third is complete crown. So the complete crown, the cuspal protection becomes more important as the structural durability of the cusp is compromised. So this is the end of the today's presentation. Thank you everyone.